So good morning, everyone. Can you hear me? Is it working? I will try not to bore you again with the same topic of hybrid. I will just talk about the ignored part of the system, the part that Lars yesterday wanted to get rid of. I'll start by talking a bit about the diesel generator. Because last year, when I joined here, I was working in a company that assembles diesel generators. So our part was, this was my daily job every day, these hybrid systems. So in the beginning, I'm a solar engineer. I considered myself very cool. And then whenever I hear the diesel generator, this is the first thing comes to my mind. Not a normal dinosaur. It's a pixelated dinosaur. So you cannot even, what, diesel generator? This is something uncool, very dirty, very non-environmentally friendly, and I hate it. But then after I joined the company and I started knowing more about diesel generators, I discovered that they are really impressive creatures. So let's call it this way. So this is a diesel generator, one of the ones that we use to assemble. A typical diesel generator will have an engine, alternator, and a control system. So just to add some depth to the topic, these guys, they enjoyed calling the engine the prime mover. So it sounds like more philosopher, something cool, a prime mover. It's just an engine, but that's how they like to call it. So a diesel generator combines the kinetic energy produced in an engine that rotates an alternator. The alternator, as we all know, rotates and produces electricity in the AC form. The control system is really smart, and that's what changed the image of a diesel generator in my mind from a pixelated dinosaur to a more unicorn or something like that. It controls the diesel generator. You can get all the information. It's a smart device, basically. So it knows when it has to switch on, even if there is any human to operate it. It knows how to communicate. If there are a couple of them in the synchronization mode, as I will be talking in a while, they speak to each other, they communicate. So I think this is all the characteristic of a smart intelligence. So they are good. They are not as bad as I was expecting. So just to give you an idea, I think Uta said I have 15 minutes, so I will just make it quickly. We need to know, first of all, what's the frequency, what's the voltage of the system we want to operate. If it's 400, 480, 380, we have different configuration, whatever you want. Frequency, 50 hertz, 60 hertz. Also, this will have an impact on the the speed of the rotor, how fast it will go. We need to know what's the application of our diesel generator. Is it going to be the prime source of energy, or is it going to be a backup? So as you know, if it's the prime, then it should not be as big as if it's a backup. Because if you have a backup, let's say for a hospital, you want to run all the loads on this diesel generator. So it should be able to withstand all the load of this hospital in the emergency cases. What are the weather and ambient conditions? I'll explain this in a further slide. And what's the connected load? So diesel generators, they are sensitive also. So it depends on the latitude, how high you want to operate them, what's the temperature, what's the weather conditions, if you have condensation, if you have high humidity, all this will have an impact. So you need to know all this upfront to know how the diesel generator, what's the best to design for your system. For example, the altitude has an impact on the amount of oxygen on the air going inside the diesel generator. So you need to accommodate for all these losses that will happen if you're going on a higher altitude. A daily load, this is what we're always talking about. This is what looks like a daily load for a school. This is a real project I did in Lebanon, where we installed 110 kilowatts in addition to another 200 kVA diesel generator. So the load profile is one of the most important factors. It's very important to measure this load profile. That's usually where many of the projects go in a loop, because you don't have proper data from the site, you don't have load profile, you don't know what's going on. And usually this is, it has so many variations through the season, through the weekend. This is the normal school during week, but during the weekend it will be all at 20, for example. Now the synchronization of diesel generator, also it sounds like a big word, synchronization. It's just not more than operating more than one diesel generator on the same bus. So all of them are working simultaneously to give the power for the load. It's very important and it's very helpful in many cases. For example, this ability allows you to extend the system later, to make it bigger, to add more diesel generators if required. It allows you to operate them smoothly. So instead of running, let's say, one diesel generator at 100%, you can run two at 50%. That's how you can do it. Of course, also there are some constraints related to available area. So if you don't have enough space, maybe for one big, you can have two smaller ones. So it all depends on site to site and location to location. Now, the light loading. Yesterday, you heard this word maybe a couple of times. Just to give more idea about it. Diesel generators usually are sized to work on a specific load or on a specific temperature. So if you're operating the diesel generator below that specific load or temperature, it means this is not the optimized condition for it to work. So for example, the seals of the engine, the internal seals, it will not be closed fully because it's not so high temperature. It will be a bit reduced in size. So many of the sludge, many of the fuel will be running out of it. You will be building sludge at the output, at the exhaust of the diesel generator. This will reduce the lifetime of the diesel generator. It will increase also the burning of fuel and the burning of oil. So the light loading is the thing that you want to avoid all the time. This is just a diagram of how 4 diesel generators are connected together in synchronization. As you see, they are all providing the load with the required power. If the load dropped, one of them will switch off. As I said, there is the controller here. It's a very smart device. It will just switch off this, it will open this breaker and switch off this engine, for example. That's how it goes. And then when it feels that there is another requirement, it will start ramming up the second diesel generator when it's required to plug it in at the right time. It's very smart, and they really can manage the whole thing. Now, why hybrid PV diesel? Again, I'm not going to say what we were discussing yesterday. This is luckily, the guys missed putting some numbers about levelized cost of electricity, so I can present something new here. We have, so we see the solar rooftop residential, it's between $187 to $319 per megawatt hours. While if we look at the diesel generator, we see it's between 197 up to 281, depending on the diesel price. So we see immediately that we can make a lot of savings on the diesel generators. One case study I was working on now, the diesel generator has a cost of 0.9, and the payback period is about 3 years. So that's an amazing project. When it was the diesel generator at 0.5, we were achieving 6 to 7 years at the payback period, which is still okay. But here it's all very sensitive to the diesel generator cost. And for this kind of projects, this is when you really want the prices of diesel to go up. This is the only time when you want, yeah, please go up. This will make my project more nice, more valuable. So just some words which I believe many of the guys talked about yesterday. Hybrid systems are either AC or DC. We call it this way depending on the bus that they are both supplying the energy at. So you either has AC coupled system or DC coupled systems. So for the AC coupled, this is the one which I love most. This is like my favorite system to work with. And this is what the guy yesterday from Sunbelt, I think this is what they are talking about most of the time. So It's called sometimes, by the way, on-grid PV diesel. So here you will have a load, and you will have a diesel generator or the grid. One of them is the grid former. So you always need an element which makes the grid. And then you plug in an on-grid PV inverter. The on-grid, I like to think of PV on-grid inverters as slaves. So they are always slaves. They cannot be a master in a circuit. So wherever they get the grid, they just synchronize with it and produce electricity. For that, it will never work with this one alone. You always need one of these two, and that's what Lars also mentioned yesterday. So this system is very straightforward. You just install it in minings, in schools, in factories, in all these places. Now, the controller, which is here, I forgot to mention it. Again, the guys talked about yesterday. It has one very important task. It's maximizing the solar system while protecting the diesel generator from light loading. That's the most important. That's the line that you should not cross in these systems. You should not go below 30% or 40% depending on the manufacturer of the diesel generator. You should not operate in the light loading. Again, this was the question that Fadi asked, how this is achieved. All the PV inverters, they should be, the operator of the grid should be able to curtail their power. This is mandatory for all the PV inverters in the world. And usually this is done in steps. So the controller here will give the signal to this PV inverter to reduce its output. And this is done by just switching from running on the maximum power point to any other point. And I think Lars explained this point very well yesterday. So he reduced the value of my presentation, but that's fine. Now, AC hybrid systems with batteries. Again, I'm not going to repeat much here. You have a system which is connected to a standalone inverter, or what the guys called yesterday, self-commuted. Yeah, self-commuted. We call it usually off-grid. It's an easier name. So this inverter is capable of generating the grid or forming the grid. And then you can add a normal PV inverter as well, an on-grid one. Here, do I still have time, or it's over? 2 minutes. OK, I'm finishing. DC hybrid systems, maybe here I can add something, which also mentioned yesterday a bit. Many of the in the telecom industry, they always try to work with this DC coupled hybrid systems. For us, we did our study at that time at the company, and we really did not find like a huge difference between a DC coupled system and AC coupled system. Just to mention for you here the difference, the main difference is the generator itself. So they use a DC generator. A DC generator is still an AC generator, but it has the rectifiers built inside of it. So the output is only DC. You don't get AC output of it. The very important feature here that the clients were referring to is that these diesel generators are less subject to stealing, because nobody would go, all these telecom stations, they are in remote places. So they are vulnerable for theft. People go to steal them. But if you have a DC generator, it's useless, because you need to really destroy it to be able to make it an AC again. So many of these companies were like keen to have a DC diesel generator because it's less susceptible to stealing, to theft. Other than that, really, we did not find like the huge impact on cost or lifetime of the diesel generator. Just one last word about PV diesel hybrids. There is a huge potential in the world because the amount of diesel generators is huge. But the potential for every project has to be evaluated individually, because really it depends too much the savings on your load profile. If you have, let's say, a factory or something that's running during the night, it doesn't make any sense to add any PV. I think here it's very important to introduce some kind of demand-side management before you introduce your hybrid system. So you can educate the guys to try to shift the load as much as possible to the daytime. One of the practices that we found always useful is to really reduce the load by introducing any other energy conservation measures, like introduce LEDs, introducing some kind of smarter HVAC systems, reduce all this stuff, and then at the end we add the solar. Of course, this means that we are installing smaller solar system, but we don't do it usually unless we have the full chain. So unless we make sure we are selling them the lights, we don't tell them about these ideas. There is a lack of know-how, and here I would like to refer to, it's not a problem, just an issue. I think even Fadi asked yesterday the guy from Sunbelt about what software they used, and they used Sunny Design. Sunny Design from SMA is currently maybe the only software in the market that quantifies for you the savings, that gives you how much you're going to save and all this stuff. Homer, really, it just stops when you have higher penetration of solar, and it just gives you an error message that Homer cannot do all this higher penetration of solar, so you need other software to do that. So it's a bit here of a gray area, and that will add costs on the engineering side, because compared to the on-grid systems, which are very straightforward and easy to be done even by one engineer, these systems require a bit of attention, especially also on the side of collecting data before the real design starts. One last point is the advancement in batteries will have high impact on this type of systems. Believe me, there was nothing worse than mentioning the word battery to any operator of these systems. People were ready to do anything. They don't want any batteries because of their very bad experience with the lead acid. I myself visited a site where the guy paid $40,000 for lead acid batteries. That was in Lebanon for a dairy farm, and he lost it in 1 year. The whole batteries, they were gone because the engineer who installed it for them, he just was not bothered about ventilating or putting an air conditioner inside this room where they have all the batteries. So after 1 year, they are all kaput or dead. So you can imagine when we went to that guy and told him, like, yeah, we can replace the batteries, he said, please, no batteries, just diesel generator and solar. That's what most of the people we faced were asking. And this way, I conclude. Thanks for your attention.
Thank you. So we can go to some questions.
Thank you, Michel, for the informative presentation. I have a question regarding the efficiency. You mentioned that the recommended load should be between 50 and 85%. But would it be better to operate it at 85 or at 50? So in terms of efficiency, I would imagine that 50% would give a better lifetime, but in terms of efficiency, what is the optimum point?
The higher the better. The higher the better. 70 or 80 is better. It's just that when you're operating at 50, so you're leaving some space in case of the load went up suddenly, so you are on the safe side. The good thing about diesel generator, maybe I did not mention it, that diesel generator, for example, can operate at 110% of its capacity for like 1 full hour every 12 hours. It can even go up to 300% of its capacity for like 20 seconds. So diesel generators are very rigid, very strong, hard machines, heavy-duty ones. So back to your question, yes, it's the higher the better, but it's always a very good thing to check is you have the energy consumption, the diesel consumption, and the loading. So you can check, you can plot this and see. You can see for every diesel generator what is the best point for operating. So usually in the data sheet, they will put for you at 100% the diesel consumption, at 75, at 50, at 25. So you can plot these numbers and see when it's operating at the best. That's another trick you can see for yourself, where is the best point to operate this diesel generator. Also, the size, for bigger sizes, might be better to go for a higher. I know for different models from the same company, there are different preferences on which point to operate. So it's a tricky question, but it's always better to ask the diesel generator supplier. They know it.
Any other question?
One question related to the experience you just mentioned because of this battery operation. And you said that after 1 year this battery was destroyed. Was it destroyed internally or was it destroyed due to oxidation of the whole installation due to acid gassing? What was the reason for this?
Frankly, I'm not sure, because we were not allowed to do any inspections. The guy just said they are done. They were at 25% of their maximum nominal capacity. I assume the configurations of the strings were not so accurate, so there was some unbalanced charging and discharging and many of this stuff. Besides that, it's also in an uncooled or non-ventilated area at all. And you know, they require maintenance. So many of the people there, like, okay, I don't want to pay this $200 per month maintenance for these batteries. They don't appreciate how serious is this. So it goes. They just go. They are flooded ones.
Okay, thank you. I understand that the damage was internally.
Yeah, it's a very old system. They are 12 volt. I think there were like 96 batteries in a area just like these two tables. There were 96 of them. So many.
Thank you.
Okay.
From the presentations yesterday and your presentation just now, it seems like we're stuck with diesel generators. There's something that's not going to go away. My question's around, like, it's fairly old technology, diesel generators. Is there much research or development in generators and improvements in reduction of noise, reduction of emissions, and improvements in efficiency?
Yes, there are lots of improvements. If you look at the European Union, they have high standards in terms of emissions for diesel generators, that you should have very high rated diesel generators in terms of emissions. So they cannot emission more than specific amount of carbon. And all this is possible because of the research in that field. But the problem here that none of the third world countries where you have all these diesel generators has any of these standards in consideration. Even the companies, which are all European companies that are assembling these diesel generators, they sell it. There are versions for the Middle East, for Africa, for all these countries. So they have the European version and they have the third world countries version, which they call it always energy efficiency, optimized energy efficiency, because you know, when you're reducing the emissions, it impacts a bit of the efficiency of the diesel generator. So they call this energy optimized. They give it a nice name, a cool name, but it's the other way around. And they all go sell it around in that part of the world. And so that's the sad thing, that let's say the waste from here, it's all dumped into that part of the world. And that's where all the carbon is being generated, all the carbon footprint. So there is not much, even if there is research, it will not have any impact because it will be all here used in Europe. And like, how many diesel generators you see here? Not so many. In Nigeria, walking in the street, you will hear diesel generators all the time around you, all the time.
Okay, thank you, Michel.
Thank you.
Michel.
Thank you.